Hello everyone, my name is Taraka Tabina with a student ID number of 13016240443, and today I will attempt to solve a problem using the Gauss-Jordan method. So for example, let's say we have these three equations right here. Most people, when they see these three equations and try to find the value of x, y, and z, they will use the normal substitution or elimination method. But the Gauss-Jordan method tackles this problem differently. By transforming the equations into a matrix, we can find the value of x, y, and z. So how can we do that? The first thing we need to do is to transform the equations into a matrix. X is the value of the first column, y is the value of the second column, and z is the value of the third column. And don't forget to substitute each value of these equations in next to the matrix. So that we got the matrix, the first thing we need to do is to make this diagonal area of the matrix into ones and the others into zeros. How do we do that? We could use simple elimination, multiplication, division, and addition. The first thing that I do to change the values is to subtract the second row with 2 times of the value of the first row. So the second row becomes 0, minus 2, minus 1, and minus 7. The second thing I do is to subtract the first row with the new value of the second row. So the first row becomes 1, 0, 0, 1. As we can see, the first row has met the condition of the Gauss-Jordan method. So we just need to change the value of the second and the third row to solve this problem. The next thing I do after this is subtracting the third row with 2 times the value of the second row. So the new value of the third row is 0, minus 3, 0, and minus 6. After this, I swap the second row with the third row. So the third column of the second row could be 0. And next, I multiply the third row with 2/3 the value of the second row. Now, due to the value of the second row and the third row being a negative value, I multiply the second row and the third row with minus 1. So it could change into a positive value. And for the last part, I divide the second row with 3. So we could get 0, 1, 0, 2. So now we could see the matrix has a structure of ones and zeros. The first row represents the x. So we could say x equals 1. The second row has the value of y. So we could say y equals 2. And lastly, the third row has the value of z. So we could say z equals to 3. Lastly, before I end my video, I need to note that the Gauss-Jordan method can be done in many ways. To prove this, I inserted the three original equations into multiple LLMs. And while they have the same answers, they calculate using the Gauss-Jordan method differently. Okay everyone, thanks for watching my video. I hope I get decent grades, and I will see you if my lecturer gave me another video project.